it again through the high levels of progesterone and the negative feedback turns off luteinizing hormone, which is required for its survival. This is very constant, 14 days, nearly all individuals, plus minus 1 day. So here we have that system, the neuroendocrine axis again that we spoke so much about. I won't go more into this, except, to go back here to the corpus luteum and show what that looks like. So the LH surge caused these changes. It caused, through prostaglandin, release or rupturing of the follicle to release the eggs, and it causes this, what is called the luteinization reaction. In other words, the formation of a corpus luteum. And that's done predominantly, the changes occur in these granulosa cells. And here is the changes that occur. You're switching off temporarily aromatase, you're no longer producing much estrogen. And so what these cells produce now is progesterone in concert with fecal cells. Now, as you can imagine, to produce progesterone, they need again this enzyme that we are assaying for. So in the corpus luteum sample that you have from the cow, we would expect HSD to be present again, so that this conversion of pregnenolone to progesterone can take place. At the very least, the outside of the corpus luteum, which is still the derivatives of the fecal cells, should produce HSD. So we'll see what happens. There you go. Boom. Now, how are we going to test this? We're testing this by adding in the substrate, that little 0.5 mil or whatever you've got. That substrate is called ethylcolanolone. So it's an ethiocolate, a type of ethiocolate. That's the structure. Now you can see immediately this is a steroid. It's actually very closely related to testosterone. Indeed, it's actually a metabolic breakdown product of testosterone. When the body metabolizes testosterone, it produces ethylcolanolone. Now, ethylcolanolone, as you may notice, look at the 3 position here. Where's the mouse? Come. Anyhow, no mouse, but my finger works. Hydroxyl group. Okay? So what does that hydroxyl group remind you? These hydroxyl groups here. And these hydroxyl groups are what HSD converts. Okay? It removes the hydrogen, the hydrogenase reaction to form the oxygen. So let's put that here, closely related to testosterone, actually a more active downstream target of the testosterone. So you can imagine that this enzyme will convert ethylcolanolone into something again that resembles dihydrotestosterone. And that is this reaction shown here at the top. It's in your lab manual as well. So HSD is the enzyme with the addition of a oxidizing agent, NAD plus in this case, causes a production of 3 oxosteroids, so these type of family, and it generates NADH. So the hydrogen is removed from here, added onto the NAD to give NADH. So obviously in that solution that you have, we have NAD plus as that substrate, but we have a further component because NAD plus to NADH you can't easily measure, but what you can measure is color. So now we're using the NADH to drive a color reaction. The NADH that's generated through the action of the enzyme we're after. And that's shown here. NADH plus this fella here, you can see it's a very cyclical product. It's colorless normally as a salt, tetrazolium blue, but when a hydrogen is added to it, it breaks up this ring structure here to form what is called a formazine, and the formazine is blue and it's insoluble. So it precipitates out wherever there has been NADH present. Okay. And that will be only in the vicinity or within the cells that actually have that enzyme. So that's why we're adding tetrazolium blue into the reagents mix. So we've given you those things already all pre-mixed. PBS in there is phosphate buffered saline. That's simply to maintain a bit of salt. Most enzymes need physiological salt conditions to work. And it contains the right pH, namely a physiological pH of 7. Phosphate buffers at that level. Right. That's it. Any questions? Now, you've probably incubated for 15-30 minutes, so what we can do is some of you can take a break and come back, and others can come with us, one of the tutors and myself, down to the basement of this building, and that's where my lab is. And in that lab also is a histology lab where there's a cryostat machine. I believe someone is currently working on it, so we'll see if we can go in. Otherwise, I'll show you some other histology stuff. And I just want you to see actually what the cryostat machine looks like. So well, I won't say more. I'll talk the rest downstairs. So maybe if half of you come with me, just leave your lab coats here.